Now, some application. Told you we'd be dealing with optimization. So here we are. We've been hired as architects to design a fitness room, a physical fitness room. And it consists of a rectangular region with a semicircle on each end. What's that going to look like? A rectangle with two semicircles on the end. What's something that we've all seen before that this is? A track. Yeah, if you look out the window, you'll see what we're talking about.
On the outside.
Okay.
I thought it was on the inside too.
Oh, no, sorry. Yeah, this looks like a track, except instead of 400 meters, it's 200 meters. Okay, so since it's inside, they made it smaller. So basically, what we've done is we're taking this rectangle, and we really don't care exactly what shape it is as long as it's made of two rectangles and two semicircles, and the perimeter has to be 200 meters. Okay? So, we're sitting here thinking about how we're going to design this, and we say, okay, well, we can make it like this. There's the rectangular part, and here's my semicircle. I need two of these, right? I'll make that big. Okay, let me. Oh, come on. Now it changes. Alright, we've got that part, and I need to move this over so we can put the other end on. Alright, so there's the track. That fits the requirements, right? It's 200 meters around. It's a rectangle with two semicircles on either end. Alright? Or I could do it this way. This would be fun. Okay? I'm going to make it like this. Alright, and... Oh, wait. It's going to have to be something like that. Let me turn this sideways and see if I made that even close to the right size. Okay. There we go. And then if I make that, flip it around, put it over here, that fits right too.
You can just draw a circle.
So, yeah, it's almost a complete circle. So which one should I build?
The second one.
Okay.
Whichever one makes you happy.
Whichever one makes me happy. Well, here's the thing. Usually if we're presented with a situation that has more than one possible outcome, that would still fit all the constraints, we think of one other thing that we want to take advantage of. Alright? We're not just building this room to be a track, are we? We probably want to have stuff inside, right? Okay. So this, and obviously these aren't to scale, okay? This is obviously way longer than this would be. But this doesn't have a whole lot of space inside it, does it? Okay? This has more space in it, alright? What we want to do, though, is we want to actually maximize, and this is what we're going to end up doing at the end, we're going to maximize the area. Okay, this is an optimization problem. In this case, the best scenario is the scenario where we get the most area inside this track. Alright, so let me get rid of both of these, because neither of these are very good. Okay, and let's draw a basic. There we go. Wish I'd done this before. Okay. So there's that side. Spin this around. We'll just draw a general one here. Okay. And it wouldn't matter if you made this sideways or like this. Just fit it on your paper somehow. Alright, so here we've drawn a diagram to illustrate the problem. A lot of times in word problems, that's kind of one of the most challenging parts, is just to get a diagram that works. Okay? But it says, let x and y represent the length and width of the rectangular region respectively. What does that word respectively mean?
In that order.
In that order, so translate here. Okay, the length is x, and
Width is 1.
the width is y. And the reason is because respectively means in that order. They said x first, and they said length first, so x goes with the length. They said y second and width second, so y goes with the width. Alright? If you weren't sure, you could also look at part B. It kind of tips you off as to what we're talking about. So y is going to be that. X is going to be this length from there to there on the rectangle. Okay? So, we have our diagram and it's labeled. Okay, make that a little bit smaller. Move that up. Okay. Any questions so far? Alright. Now, part B, determine the radius of the semicircular ends of the track. Determine the distance in terms of y around the inside edge of the two semicircular parts of the track. So now, in terms of y, we want this distance plus this distance. Okay? Well, why are they saying in terms of y?
Y is the diameter.
Y is the diameter. Okay? How could I give the radius of the semicircle in terms of y? It's half of y. Okay? The radius is 1/2 of y. So then, what's this distance and this distance combined?
Pi y.
Y.
2 pi
Y.
y. 2 pi y.
The area.
Just pi y. Pi y.
2 pi y, pi y.
2 pi y.
Pi y.
Alright.
Y pi.
What do you guys think?
2 pi y.
Some of you are just sitting there silent. Chime in.
Pi y.
2
Okay.
pi y.
Let's work it out. What are we really finding here?
The area.
Not area yet. Distance around would be circumference. What's our and notice we have two semicircles, that makes one whole circle. So circumference equals, what's our formula?
Pi y. Pi d.
Pi times the diameter,
Or 2
or 2 pi r.
Yeah.
Either way, when you plug in your 1/2 y
Pi
for
y.
r, you get pi y. Alright, pi y.
It's gonna be a trend.
Okay. So, now I want you to try C, D, and E. And you guys already have your partners, but go ahead and try C, D, and E together. We've set up the problem, we've gotten you this far. Okay? We're using this to help us write an equation in terms of x and y for the whole distance around the track.